Objective: to understand how the charge-to-mass ratio of an electron was measured by JJ Thompson. As you know, the atom is the smallest particle of matter, and electrons are subatomic particles present within an atom. How was the mass of an electron measured? Was an instrument used to measure it? Surprisingly, no. How then could scientists measure the mass of an electron? Let's find out. Charge-to-mass ratio of an electron. Once the electron was discovered, JJ Thompson continued his efforts to calculate the charge-to-mass ratio of an electron through experiments. The experimental setup included a cathode ray tube. With a cathode, an anode and a metal plate. The anode he used in the experiment had a slit. At the end of the tube was a large sphere, coated with a phosphorescent material so that any beam after striking it would leave behind a mark on it. It was also provided with a scale to measure the deflection. At high voltage and low pressure, cathode rays were produced in the cathode ray tube. In the absence of electric and magnetic fields, the cathode rays produced were found to travel in a straight line without any deflection and struck the tube at point A. When an electric field was applied, the cathode rays were found to deviate from their straight-line path and hit the tube at point B. Similarly, when a magnetic field was applied, cathode rays were found to deviate from their normal path and strike the tube at point C. When both electric and magnetic fields were applied perpendicular to each other and to the path of the cathode rays, the rays showed deviation. Thompson observed that the amount of deviation of cathode rays depended on three main factors. 1. The magnitude of negative charge on the particle. The greater the negative charge, the greater was the deflection. 2. The mass of the particle. The lighter the particle, the greater was the deflection. 3. The strength of the electrical and magnetic field. The stronger the field, the higher was the deflection. Thompson calculated the charge-to-mass ratio of an electron by accurately measuring the deflection of electrons when varying strengths of electric and magnetic fields were applied. His efforts culminated in measuring the charge-to-mass ratio of an electron, which was found to be 1.758820 into 10 to the power of 11 coulomb per kg.
Let's summarize. The E by M ratio of an electron is equal to 1.758820 into 10 to the power of 11 coulomb per kg.